Okay, yeah, here we have the notes for section 10.5, tangents. So there's our main ideas and vocab. So when you're talking about a tangent line, you're talking about a line that intersects a circle or touches a circle at exactly one point, and that's the point of tangency. So it doesn't cross through the circle, it doesn't start on the edge of the circle and goes out. If you extend, excuse me. If you extend it, it would still only touch the circle at one point. Okay, so here we have theorem 10.9, which just states that if a line is tangent to a circle, then it's perpendicular to the radius drawn to the point of tangency. So in this case, RT is the tangent line, OR is the radius. So since RT is tangent, OR and RT are perpendicular, or they form a right angle. Okay, so example 1, ED is tangent to circle F at point E, find X. So since you know that ED is tangent to the circle, that is a right angle there. And if that's a right angle, this DEF is a right triangle, so you can use Pythagoras on it. So leg squared plus leg squared is equal to hypotenuse squared. So 25 is equal to x squared, so x is 5. So here we've got theorem 10.10, which is actually the reverse of 10.9. So 10.10 says that if the line is perpendicular to the radius, then it is a tangent. So 10.9 was the reverse. If it's a tangent, then it's perpendicular. Okay, so example 2, determine whether MN is tangent to circle L. So if it's tangent, that means this triangle, LMN, is a right triangle. So I need to check Pythagoras once again to see if it's a right triangle. Now for this one, you do not know the full length of LN, you only know ON. However, L to M is 3, which means L to O is also 3, because they're both radii. And that means that is 5. So leg squared plus leg squared, is that equal to the hypotenuse squared? Well, we already know that that's 25, and that's 25, so yes. So here we go, another example, same problem, or a similar problem. So SP is 4, RQ is 4, and QP is 5. We also know that RS is 4, because it's another radius. So that's bad. That whole thing is 8. So is 4 squared plus 5 squared equal to 8 squared? So that's 16 plus 25 equals 64. That is not true. So that is not a tangent line. Okay, theorem 10.11 here states that if you have two segments from the same exterior point, in this case A, are tangent to a circle, so AC and BC, or sorry, AC and AB are both tangent, then they are congruent, they are the same length. Okay, example 4, find X, assume the segments that appear to be tangent to circles, sorry again, are tangent. So AB and AC both are tangent, so that guy is congruent to that guy. AC and AD are also tangent, so that means AD and AC are also congruent. So all three are equal to each other. So I can set AB equal to AD and solve. I'm going to bring the x's this way. So that's 8x plus 5. Bring the 5 over. And then divide by 8. So x is 4. So it's transitive property. If A is equal to B and B is equal to C, then A and C are equal. And our final example is going to use a similar trick. So ABC is circumscribed about circle O, so that means the triangle is outside the circle. Find the perimeter of ABC if EC is equal to DE plus AF. So let's fill in what we know. So that guy's 6 because that one's 6. That one's 19 because that one's 19. Now I do need to find EC and BC. I can find EC using this trick. So it tells me that EC is equal to DE, which is 6, plus AF, which is 19. So EC is 25. And if EC is 25, BC is 25. So to find the perimeter, that side's 31. That side is 25. And that side is 44. So 31 plus 25 plus 44. Oh, that's 56 plus 44 is 100, is your perimeter of your shape. And that's the end of the section.